line, it's going to be moved up or down. I got to tell you what it's going to be though. It's going to be, this is the weird part, the leading coefficient of the numerator divided by the leading coefficient of the denominator. So do you remember when I used this abbreviation LC to represent leading coefficient back when we were doing polynomials? LC, leading coefficient, is just the number in front of the power of x. So look at this first example here. The leading coefficient of the numerator is this 3. And the leading coefficient of the denominator is the 1. You see that? So for this example, if I asked you to graph this, when you got to this step, you would say case 3, you would say the horizontal asymptote is y equals 3 divided by 1, which is just 3. So if you think about what the graph would look like, here's 3. It would be a dotted line out here and out there like that. So it's like your little magnet line at the edges would just be raised up 3. Understand? Or do you kind of see? No? Question? How about this one? Same degree, right? So what are the leading coefficients? -2 and 1. So here your horizontal asymptote would be y equals -2 over 1, which is just -2, right? So this graph would look like this, right? Here's -2. It would be out here and out here. This one, same thing, right? Same powers. So you go leading coefficient here and here. So y equals 1 over 2. Well, 1/2 is just 1/2, right? You can't do anything about that. So it would look like this. Like if this is 1, right, here's a half. You would have dotted lines out at the edges like that. All right? Case 3 is the only time you look at the numbers in front. The other cases, you don't even look at those numbers. They're irrelevant. All right, so last example here. Let's do, which one? Let me see, hold on. 3 minus 3. We can do this one. Let's do this one right here. Let's graph this one. F of x equals 3x squared minus 27 over x squared minus x minus 30. First step, x-intercepts, right? So step 1, x-intercepts, set the top to 0. What would you do to solve that equation? Anyone have an idea? GCF, what can you pull out? Okay, pull out a 3. You'll be left with x squared minus 9, right? Ooh, that looks familiar. X squared minus 9 is x plus 3x minus 3. And now you set each of your factors equal to 0. How many solutions do we have here? Just 2, right? Remember that when you pull a number out and you set it equal to 0, you can ignore the number. Like if this had been a 4, it's irrelevant. 4 can never be equal to 0, so we just ignore it. These are the places we get our answers from. So -3 and 3. Two x-intercepts. Okay, verticals. Set the denominator to 0, right? All right, factor that. I made it factor, minus 6 plus 5. your two verticals are 6 and -5. Shit. That means I have 2 of these and 2 of these. I have 5 test points, right? Third step, horizontal asymptote. All right, this is where we would do what I showed you just a second ago. We look at the degrees. They're the same, right? Since they're the same, now I defer to the leading coefficients. The leading coefficients are what tells me where the horizontal is. So 3/1, my horizontal, this is numerator equals denominator degree. This is case 3. And therefore y equals 3/1, which is 3. I don't need to explain that, right? Because we just went through that. Picture time? Picture time. Starting with my x-intercepts, -3 and +3. Here's 3. Here's -3. Verticals at -5 and +6. What else? The horizontal, right? We have the horizontal now, and it's at 3. So this is where it's important. I'm going to do this one in red so you really see it. If I go up 3, let's say 3 is here, I'm not going to do a dotted line across the whole thing, right? I'm just going to go out to the edge over here, the left side. I'm going to put a dotted line out here, and then over here, I'm going to put it out here like this. And I just have to remember that when I draw my function on the left-hand side, it's going to get pulled towards this thing, right? It's going to get pulled towards this dotted line. Over here, it's going to get pulled towards this dotted line. And now, test points, right? 5 of them. What should I pick to the left of this? Maybe like, I don't know, -6, -7, -10, anything you want. I'll go -7. Between here and here, there's only one good number, -4. Between these two, 0 is a good one. Between here and here, I could do 4 or 5, so I'll do 5. And then over here, anything I want, I'll use 8. Does anyone have a question on how to like pick the test points or like, you know, making sure you get the ones you need? All right. Okay, and then you plug those in, right? Now, I'm not going to go through that process. That's the really crappy, tedious process. So I'm just going to tell you what it is, okay? When you plug in -7, you're going to get a positive number. So that means I put a point anywhere I want up here. Anywhere. I'm going to put it right there. At -4, you're going to get a negative number. It'll be down somewhere. At 0, it'll be positive, so put it wherever you want. At 5, it'll be negative. And at 8, it's going to be positive. I'm going to put it way up there. Do y'all believe me? Trust me? Yes? Yes?
So for like 8, how you went over the
Yeah.
horizontal asymptote?
I did that on purpose. Because I knew it might trigger you to ask, you know, like, what are we going to do with this? It doesn't matter if you put this point above or below. That's why I don't want you ever drawing it all the way across. Because if you did, you'd be like, where do I put it? And it would cause problems when you try and draw it. So just put it out at the edge.
Will it affect how the line looks?
It's going to look weird, but it's not going to be wrong in the sense that it'll be above the x-axis and the behavior is going to be, well, let's just draw this one. What's going to happen to the left? I've got my barrier, right? So it's got to go what? Up? Okay. And as I draw it to the right, it's got to flatten out towards that. Right? That's what it looks like.
But if you were to draw it below the...
So if I had drawn it below, let me do it in different color, just so you can see the difference here. If you would have plugged in 8 and put a dot, let's say here, not so high, right? Then to the left, it would still go up, right? And to the right, you would flatten out, but you would do that, wouldn't you?
What would make you say that it wouldn't go down? Or 'cause it would create like-
Oh, it wouldn't go down?
Yeah.
No x-intercepts.
Yeah.
I only have x-intercepts here and here.
Okay. Yeah, that makes sense.
That makes sense? So even though these two pictures look different, they both behave the same way. They're both above the x-axis. To the left, they go up, and to the right, they flatten out.
So you can cross the vertical.
That's right. You can cross. It doesn't matter which side. You're just getting closer to that number. It's not like a vertical asymptote. Vertical asymptotes are barriers. You cannot cross them. Horizontals are like magnets that pull you towards them. There are functions in math, not ones we'll study here. There are functions that exist out there that have a horizontal asymptote like this, and the function does this. It like oscillates and it keeps crossing it, but the further you get out, it's just getting like funneled in closer and closer. But it's always going above and below it. Does that make sense? So the definition of a horizontal asymptote is a little different than a vertical. The vertical is a barrier, no touching it. You cannot touch that. The horizontal pulls your function towards it. The further you go to the right, the closer you get to the line. All right, so see the difference between putting a point down here and up here? These would both be correct answers, but you can't have them both on there, right? Because that wouldn't be a function. So I'm going to erase one of them. I'm just going to erase this one. Now, when I put my test points, when I did them, do you notice I put this one above and this one below? I did that on purpose so you could see both scenarios. So this one would flatten out towards this, right? And then to the right, you might be thinking down, right? But you can't go down. There's no x-intercept, so you actually have to turn back up. Any questions there? Can y'all see what happens in here? Can y'all see this?
Wait,
Yes.
So, just one more time.
Yeah.
The horizontal you can cross. The vertical you can't though.
Where did I cross it? Did I cross this somewhere?
Well, no, I'm just thinking because like, I don't know, I was just wondering.
If this line were extended across, then I would agree that I crossed over it, didn't I?
Yeah, oh yeah.
But that's why I'm telling you don't draw it across, because it's not the horizontal asymptote tells you nothing about what happens in the middle of the function. It only tells you what happens at the edges. So by me going up, I'm not crossing anything because this horizontal asymptote is only valid out here. Does that help a little bit? The biggest mistake I see, not from you or just frustrates me, when my students go to the tutoring lab, the tutors draw the damn horizontal asymptote all the way across. It drives me crazy because that's the way they learned it, and it's such a problem. When you draw that all the way across, it just creates such an issue because you start, what if this thing went like this, right? What if it did? What if these dots were above? It would go like this, right? But if the horizontal was there, you would be like, wait a minute, I can't cross, and it just confuses students. So it's already confusing enough having it just out here, right? So just draw your horizontals at the edges, and just remember that whatever happens in the middle doesn't matter. What's relevant here is that your graph just gets pulled towards it at the edge. That's all that matters. Pull towards it. Okay?
So at the end of the graph, it can't touch it? So like if that line were to continue, like going that way?
It's not supposed to touch it.
Okay.
That's right. It's supposed to get closer and closer. For rational functions, that's the case. In general math, you can have a function actually touch the horizontal.
But in this scenario.
With rational functions, it will get closer without touching. Yeah, I always hesitate to say it's this way if I know it's not in other cases, but I will say in this case, yes. Any other questions? You're asking questions. This is good. Can I finish drawing it? All right, I'm going to do what I think I know is pretty straightforward, which is like, I kid around kindergarten, right? I'm like, connect the dots. I'm going to go here, 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 here. Those all connect together, right? There's nothing in my way for doing that. But as I continue this drawing to the right, it's kind of clear from the picture that it's going to go down, but it can't go up because there's no x-intercept. So it must continue down. And then the same argument could be made on this side. There you go. There it is. you're going to need to practice a few of these, right? Think about on your next test. I can't ask too many of those, right? I can maybe put 1 or 2 of these at the most on your test, right? Because it can take you a while to do the problem. All right, so let me put some problems on the board for you. These I'd like for you to do for homework, all right? I'm going to give you, how about, does this sound okay? I give you like 1 of each case, or do you want like 2 of each case? I'll give you 2. You do what you feel you need to do, all right? So this is homework. I am not going to collect this, all right? I'm not going to, but I am going to expect that you do it. If you don't do it and then you get to the test and you don't know how to graph a rational function, that's on you, all right? You have to ask for help if you need it, all right? So let's say number 1. Let's do case 1. So I'm going to make the numerator's degree smaller than the denominators. I'll do an easy one first. X plus 6 over x squared minus, let's go plus 3x. That's a case 1. Number 2, I'm going to do a case 2. So what I'm going to do is case 2 is the degree of the top's bigger than the bottom. So all I'm going to do is I'm going to flip that one over. That would be case 2. Those graphs look completely different. And then for case 3, that's where they're the same. I'm going to do, let's go with x squared plus 3x over, you know what, let's make that 4x, just so I can get a nice x-intercept in there for you. So this is going to be at x plus 2, x plus 2. There we go. Case 1, case 2, case 3, right? Now I'll give you three more, case 1, case 2, case 3. So the fourth one, let's go f of x is, and how about I make these a little bit harder, right? I'll make these a little bit more challenging. More challenging means probably more test points, more verticals, more things to keep track of. So x squared plus 3x minus 54. Make sure I got that right. Positive 9, negative 6. Positive 9, negative 6. And then on the bottom, x cubed plus 3x squared. Yeah. Yep. That's case 1, right? Degree of the top's smaller than bottom. All right, so number 5, let's just flip that over. The good news about me flipping it over is that you only have to do this factoring once, right? You don't have to go through this twice. How are we doing on time? Good, good. And then the 6th one, let's go with 2x squared minus 5x minus 3 over, let me see here, 2x. I got to make sure this works. I don't want to send you with something that won't work. Where do I want it? X minus 1. There. All right, there's a case 1, a case 2, case 3. Right, case 1, 2, 3, harder. Case 1, 2, 3, easier. Any questions? All right, we're not ready to roll yet. I know you're ready to roll, but just hang tight, all right? There are no questions on rational functions? Yes? If you want to take a picture of these, you can, if you haven't written them.
Like 5, whenever you don't plug in the number, you just count the positives and negatives.
Wait, say again?
You know how whenever we're trying to figure out if it goes up or down, you just circle the positive or negative?
Trying to go up or down?
He's talking about like plugging in the numbers.
Yeah,
Yeah.
uh-huh.
How do you do that? I just like forgot how to do that. Like,
Okay, so like when, you're saying when you have a test point and you want to plug it in and figure out if it's positive, negative, you have to have factored these first, right? So let's say we factor this, right? Do y'all want to factor this with me real quick? Save you some time on your homework. How can you factor the top of that? Pull x squared out, left with x plus 3, right? That's the top factor. Can't do anything more with that. On the bottom, this quadratic should break down to be plus 9 minus 6. What two numbers multiply to be negative 54, but add up to be positive 3? It's positive 9, negative 6. So I'm not showing this, but I'm trusting at home you could factor this. First, yes? Like if you were given enough time, you could factor this, maybe? No?
yeah, I got that.
Okay. So now imagine I'm doing my test points, right? And let's say my first test point, and I'm just making this up, completely making this up. Say my first test point is 5, right? And I want to plug 5 into this function. Instead of plugging it in here and having to do like 5 cubed plus 3 times 5 squared, and then 5 squared plus 3 times 5, instead of figuring that number out, I'm going to plug 5 into this. And just think about the signs. What's 5 squared? 25, right? It's a positive number. Times, and now what's 5 plus 3? Well, that's 8. That's still a positive number. This is what you're asking me to explain, right? Okay, so that's positive, understand? And then over, now what's 5 plus 9? That's going to be a positive number. Times, and then 5 minus 6 would be a negative number, right? And now I just use what I know about numbers. Positive times positive is positive. Positive times negative is negative. And then a positive divided by negative is negative. Is that what you need a clarification on? You sure?
Yeah, it's just weird seeing about the numbers, so I was like, how do you do that fast?
Well, and I'm not figuring out what the number is, right? I'm just figuring out whether or not it's positive or negative.
Put it above or
To go above or below the x-axis. So the problem is this. You can't do this same thing without it factored. You can't do it here. So the reason is this. Let's say that you determine that this right there was a positive number. And then you say plus, right? Plus some, let's say you determine that that's a negative number. What's a positive plus a negative? It depends, right? You can't tell me that a positive plus a negative is going to be positive or negative, right? I could say, what's 5 plus negative 7? Well, that's negative, right? But 5 plus negative 3 is positive. So when you add or subtract positive or negative numbers, you can't tell what the answer is. But when you're multiplying and dividing, you can, which is why you have to work with the factored version. I hope that helps and doesn't confuse you.
yeah.
Do you want to show another test point, or you're good?
I got it.
Okay, any other questions? Yes?
When we're taking a test or something and you want us to show our work, do you care if we show like that, figuring out the positive and negative bit?
So how do you intend on doing it?
Well, because I can just plug in 5 in my head and then I can just keep track of each bit.
Okay, so you're
Just
saying,
keep track that.
that's okay. I don't mind if you do that. If you want to plug in 5 and keep track wherever you want to do it, here or here, are you saying, are you going to
Yeah, no, so yeah.
You're gonna do it in
I have
here.
everything factored out already.
Okay, yeah,
Figured out
that's
stuff.
okay if you do it mentally.
Yeah, I just didn't know if you wanted us to like actually write down.
You don't have to write this down. If you just do that mentally and just be like, okay, if I plug in 5 in here, I got positive, positive, okay, top's positive, positive, negative, okay, bottom's negative, positive over negative, that's negative, okay. You don't need to write it down. This is just to show everyone what I'm doing.
Just the echo.
Yep. But if it's wrong and you did it in your head and I can't tell why it's wrong, here I can see if someone did like accidentally put negative here and then negative and then negative over negative is positive, I would see, okay, their mistake was just right there. Everything else they did is correct. That's going to be easier for me to be gentle in the grading as opposed to someone who just has a picture but everything's wrong but there's no work. I'm sure you'll show your other work, but I'm just saying when there's not a lot of work and there's just pictures, that makes me think people are just graphing it on their calculator and not even knowing what to do. So, any other questions? This is an important assignment. Make sure that you know how to do these problems because our next test, which I don't even know when it is, I'll look, is going to be what we finished our last test with quadratic functions, right? We did the whole rock dropping off a bridge or whatever it was. Our next test is going to be polynomial functions. That whole thing with the table, remember the table, up, down, bounce, cross thing? We've got all that to worry about. Then we've got this to worry about. And then we have the new stuff that we're going to do after this. But that's a majority of the test, polynomial and rational. I don't anticipate that your next test is going to be more than 5 questions. I mean, it can't be more than 5 questions, right? It's going to take you a while to do the problems. Yeah.
Our next test is our last test before the final, right?
I don't think so. I'll look. I have it right here. I don't think it is. So this is going to be one of those exams where it's just kind of like high stakes, right? You get one problem wrong. Ooh, Halloween. It's scheduled for Halloween. That's exam 3. Then we have an exam 4 in late November, and then we have our final exam. So we have 4 exams and a final.
And you said you're dropping a test grade?
What? I don't think I said that. I think what I said is that I'm not going to, and this goes for all my classes, I'm not going to let one exam score ruin your grade, but you have to show progression. You have to show improvement. Like if you have one bad exam and that's a fluke exam, that's one thing. If they're all bad and you want me to get rid of the worst one, that's a different thing. So anything I offer, I will offer to the whole class. Okay, there's no like, oh, okay, yeah, for you, I'm going to drop your lowest test, but for you, I'm not, right? So it'll be fair across the board. The way I look at it is this. Do well. Show me that you had one bad test, then we talk, right? Show me 4 bad tests, and then don't be asking me to drop a test, right? I don't know if that makes any sense, yeah. I don't like going into a semester or at any point in time with the idea that, you know what, I get one free one. Like there's one test I don't need to worry about, right? I don't like that whole approach because then people feel like they can blow off something and this material, I think for me this material is like, all right, if you can do this, you've done almost everything I'd want you to be able to do coming out of this class as far as having to process a bunch of stuff and keep it in order. All right, I want to do one last thing. I've let y'all go early a few times this semester. I'm going to keep you here for a few more minutes. I want to get us introduced to the next idea. All right. So I would like to see someone has a sacrificial piece of paper. Let's see, it looks like we have one coming. Okay, we got one already. All right, here we go. Thank you. All right, so we have studied now linear functions, quadratic functions, polynomial functions, and rational functions. They all look different, right? Lines, parabolas, polynomials, rationals are just crazy, right? All sorts of shit happening, depends on case 1, case 2, how many verticals, all sorts of things, right? And each of those functions has a different role in the real world. I haven't shown you a lot. I know with parabolas I showed you, a lot of different places. Rationals, we talked about, like lifespans and things that taper off to nothing. I'm going to now introduce you to a new function that nothing we have up to this point can do what this function does, all right? We need this function. And it's pretty easy to demonstrate visually. So I'm going to give you a few examples, probably only one example today. We'll see, I might be able to get two. So right here I have a rectangle, right? Everyone see this rectangle? I have one rectangle. And what I'm going to do is I'm going to make a t-table. A t-table that says here the number of folds that I have in the paper, and then here's the number of rectangles that you see. So right now I have not folded the paper, right? There's no folds in the paper, and you see one rectangle. No folds, one rectangle. Now I fold it once down the center, and I open it up. And I guess I could draw a line there where I folded it so you can see it, but how many rectangles now? They'll see two, right? Two rectangles. So one fold, two rectangles. All right, now if I fold it and then fold it again and open it up, how many rectangles are we going to see? Four? You think so? Four? Right? Yeah, four. Four rectangles. So that was two folds. Four. How about three rectangles? What do we got? What do y'all think? 8? Any others? What do you think the most common other answer I hear is? 6. Is it 6 or is it 8 or is it 9? What is it? Let's see. Can y'all tell or no? It's 4 across the top, 2 down, right? So it's 8. 3 folds, 8. Let me go again. 1, 2, 3. Fourth fold. Open it up. How many? Think 16? What does it seem like is happening here? Every time you move down, what happens to the number of rectangles? Looks like it doubles each time, right? We're multiplying by 2 each time. So if I go here, I get 4 across the top, 4 down the side, right? 16. Go again, again, again. One more. What do you think? 32, right? So if I open this up, it's getting hard to fold. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4. So I have 32 rectangles, 8 across the top, 4 down the side. So looks like I've got this, right? Okay, got the idea? So my question to you now, because it's getting hard for me to fold. This 6th fold is hard, 7th is really hard. I don't know if I could do it. 8 folds, 9 folds, 10 folds, right? So my question is, if I continue this down, right,